So today we'll do the next part 3 of alcohol, phenol and ether. Part 3 of alcohol, phenol and ether. So next question is 12 number asked in 2009. So ethanol is given in presence of phosphorus tribromide. So this is your ethanol. It react with PBr3, produce X, then alcoholic KOH, potassium hydroxide, then produce Y. Again it react with sulfuric acid H2SO4, and second it react with water and heated. This is your room temperature, right, and producing Z. So see how it is working. So you have to tell me what is Z, right? So see, so I will write the molecular formula for ethanol. So it will be C2H5. This is OH bond, right? When it react with phosphorus tribromide, so OH will be removed and Br will attach. So it will form then C2H5Br, right? And in presence of alcoholic KOH, removal of HBr will be done. So write this compound in molecular form. So it will be C, here Br, H, 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 H. So what does alcoholic KOH do? It removes the alkyl halide. Remove alkyl halide. So it is minus, this is plus. Bromine, why it is minus? Because it contains 7 electrons in last orbit, right? So it is more electronegative as compared to carbon. So carbon will become plus, right? So next this will be H plus, this will be minus. So now see what will happen now. This H plus go with this Br minus, right? So formation of cation and an ion is there. So this become minus and this carbon will become plus, right? So minus and plus will form a bond. Then it double bond will be here. So this is the formation of ethene, right? Name of this compound will be ethyl bromide. Ethyl bromide. This is your ethanol. This is phosphorus tribromide. Tribromide. So what does alcoholic KOH do? It removes the alkyl halides from alkyl halide only, right? So write it down. Then I will tell the next step when it reacts with sulfuric acid. Now see the next part. CH2, right? So when this ethene react with sulfuric acid, so I can write sulfuric acid as HO HSO4. So it is nothing but is your sulfuric acid H2SO4, right? So what will happen now? So this part is minus, this whole part. So I will write with different color. This minus and this whole part will be plus. In the similar manner, distribution of electron will happening. So this will become minus after gaining the electron, and this will become plus. So formation of CH2, and here what will come? Here OH will come, right? Because plus will attract minus, and this is your CH2, so it will attract HSO4, right? So this is your plus part, and this was minus part. And again it react with water, so it is H plus and OH minus. Understood? So this is the weakest bond because this is your bulky group, right? This is your bulky group. So it will break down its bond. So minus will attract this plus and this go with this one. So sulfuric acid will be coming out, right? HO, HSO4. So that's why H2SO4 here acting as a catalyst, right? And this is your formation of alcohol. This is your alcohol. So methyl, this is also ethanol. So we have started from ethanol and formed ethanol only, right? So you can see the previous slide. This is your ethanol. We have put phosphorus tribromide to form the ethyl bromide, right? And after alcoholic OH, it forms again double bond, ethene. And when it reacts with sulfuric acid, here it forms complex compound. After reaction with water, it forms again ethanol. So write this one, next part. Now look at the next numerical, that is 13. So compound of molecular formula is given like HO CH2 dot CH2OH. It react with periodic acid. Periodic acid. Right. Asked in 2009. So how will you do? So first I will write this in a structural form. So this is your molecular formula. So I will write as a structural form like CH2. This will be OH. And here one bond is there. Again OH. Right. So it react with periodic acid. So it will be HiO4. Right. So what will happen? So it will do what? Removal of water. Right. So formation of aldehyde is done. So it will form like, so 2 aldehyde will be done. So ये थोड़ा गलत हो गया, this part. So this all converted into aldehyde part. So it will become H C, right? One C is there. It will be double bond O or H. This part. So one hydrogen is removed from here. This hydrogen and this hydrogen, right? So it is converted into aldehyde from alcohol. This is your alcoholic part. This is your aldehyde part. In the similar manner, lower part also converted into aldehyde. So it will be H C double bond OH. So by combining, you can write like 2 moles of CHO is formed, HCHO. Understood? So hydrogen is removed from there. So it does reduction, right? Right. So it is removing the hydrogen. Name is given periodic acid. So write it down. Next question is very simple. It is asked about only molecular formula. General molecular formula which represents the homologous series of alkanol. Alkanols. Right. So asked in 2006. So general formula. So it will be CN H2N plus 2O. So this will be the general formula for alcohol. Alkanol is also called as alcohol. So it is also can be written as ROH. And R formula we know CnH2n plus 1OH. So here H is taken. So it becomes CnH2n plus 2 O, alkanol. So here plus 2 or O, plus 2O. Understood? So you can write in this form also. This is the general formula for alcohol. R is your alkyl group. Write it down. Now see the next question. 15. Ethylene oxide. Ethylene oxide when treated with Grignard reagent. Treated with Grignard reagent. RMGX. So what it forms? So see, ethylene oxide will be, the structure will be cyclic like CH2, CH2, here O, O. This is your ethylene oxide. React with Grignard reagent. Suppose I am taking, instead of R, I am taking CH3, Mg, and X will be Pr. So this whole part will become plus and this will become minus. So as we know, oxygen contains 6 electrons in its last orbit, right? So breaking of this bond will be happening here. Suppose I am breaking from here. So this electron will be coming towards oxygen. So it forms O minus. This is your CH2. This is your CH2. So it becomes plus. So plus will attract this minus and this plus will go with this. So formation of OMG, PR, CH2, CH2, here CH3 is there, right? When it react with alcohol or water, suppose. So water in water it is H plus and OH minus is there. So this is your bulky group. So breaking of bond will be happening here. So this again become minus and this become plus. So this will attract this H plus and OH minus go with this, right? So formation of OH, CH2, CH2, CH2. So this is clearly seen that it is a primary alcohol. So you have T primary alcohol. So you have to tell which alcohol will be formed, primary, secondary, tertiary. So this is the formation of primary alcohol. Now see the question number 16. 16. Which of the following will not form a yellow PPT on treating with alkaline solution of iodine? So yesterday I have given you the examples of like that, right? From ido form. PPT yellow color means it is doing ido form, halo formation, right? So I will write the structure now. So first option is, it is given in this form, CH3, CH, OH, CH3. So write this in structure form. So it will be CH3, CH here, OH here, CH3. So you can see this is 2 degree alcohol, right? Now see the B option, that is CH3, CH2, CH, OH, CH3 is there. So draw this structure, CH3, CH2, CH, OH here, CH3. So this is also 2 degree. Next one is CH3OH. Next D. This is your C part. D is CH3, CH2OH. Right. So C and D is alcoholic. Right. So iodoform test is exhibited by, I will write here statement. Iodoform is given by ethyl alcohol. Right. So ethyl alcohol is this one. So this can give the iodoform test. Acetaldehyde. Acetal means aldehyde. I will write here acetal aldehyde. Right. Next is acetone. Acetone. Acetone means ketone. It is given by ketone also. Right. Acetaldehyde means it will be RCHO. General formula. Next is methyl ketone. Next can be methyl ketone like CH3, C double bond O, CH3. And those alcohol which possess. So you can see clearly here. This is the iodoform group it can give. It is also given. So here this group is fixed, but here only one carbon is there now. So how can we make the byproduct? So this is not possible. So D will be the answer, which is not giving iodoform. Okay. Please write this then. Now look at the question number 17. N-propyl alcohol and isopropyl alcohol can be chemically distinguished by. So how can you distinguish? So see here. So N-propyl formula will be meth eth prop. Here OH will be there. Isopropyl means meth eth prop. Here OH is there. So secondary alcohol will be there. So here it is 2-degree alcohol. This is your 1-degree alcohol. So this is the difference between these two. So how will you convert? So N-propyl alcohol, isopropyl alcohol can be distinguished by oxidation, right? So suppose I am doing oxidation of first this one. So it will form aldehyde. Oxidation I am doing of first degree alcohol. So I will use K2Cr2O7. And earlier I have told now in the previous class. So when 1-degree alcohol do oxidation, it forms aldehyde. So this part will be converted into aldehyde. So it will be C double bond OH. So removal of hydrogen will be done here, right? And formation of aldehyde group is formed. So 1-degree converted into aldehyde and 2-degree aldehyde is converted into 2-degree alcohol converted into ketone. So suppose here H is there. So this H and H will be removed. So it forms ketone, right? Double bond O CH3. So this is your conversion of 1-degree alcohol and 2-degree alcohol. So this is the difference between these two, N-propyl alcohol and isopropyl alcohol. Now look at the question number 18. Which of the following is correct? On reduction, aldehyde gives secondary alcohol. Wrong है. उल्टा करते हैं तो 1-degree alcohol मिलेगा, ठीक है? तो 18. तो करेक्ट. तो देखो मैं अभी स्टेटमेंट को भी एक्सप्लेन कर देता हूँ. जैसे aldehyde, this is RC double bond OH. So this is the general formula for aldehyde. So when we do reduction means when we use reducing agent like LiAlH4, NaBH4. So what it does, it converts and it produces hydrogen, right? So hydrogen will be one added here and one hydrogen will be added here. So it convert into alcoholic form. So it will be RCOH HH. So this is 1-degree alcohol, right? So option A is wrong. It is giving 2nd-degree alcohol. So it produces 1-degree alcohol, right? So this is the reduction. So when you convert aldehyde, so it forms into alcohol. And when we do oxidation, reverse reaction, oxidation. right? By using K2Cr2O7, KMnO4 or PCC. These all are oxidizing agent. So what will happen? Removal of this hydrogen will be done and formation of aldehyde will be formed, right? So this is the reversible reaction. When we do aldehyde reduction, it forms alcohol, and alcohol, when it does oxidation, it forms aldehyde. So this is the reversible process. So next statement. Now see, the next statement is reaction of vegetable oil with H2SO4 give glycerin. No, it is not required. Okay, so that is also wrong. Second one is alcoholic iodine with NOH give iodoform test. So it can give, right? So I will write the explanation for C option. So suppose I am taking C2H5OH ethyl alcohol, it react with 4 molecules of iodine plus NOH. So it forms CHI3 plus sodium iodide plus HCOONA plus H2O. So this is the answer for that. So here iodoform we are producing. Iodoform. This is a color of pale yellow. Pale yellow. Okay? So write this reaction. So as aldehyde converting 1 degree alcohol in the similar manner, suppose I am using ketone RC double bond O. So when it does reduction, right? So it forms 2 degree alcohol. So reduction means addition of hydrogen, right? So 2 hydrogen, 1 hydrogen is added here, 1 is added here. Reduction in presence of lithium aluminum hydride, sodium borohydride. So write the name of this compound also. These all are reducing agent. This is your sodium borohydride, right? This is earlier I have told, right? So this all act as a reducing agent. Platinum, nickel and palladium also. These are metals which also act as a reducing agent. Reducing agent. So addition of hydrogen will be done. So here forming R, C, R, here 1H, here OH. So this is your 2 degree alcohol. In the similar manner, when 2 degree does oxidation, right? So it forms ketone. So this will be the formation of ketone after removal of this H and H. So it can be done in presence of KMnO4, K2Cr2O7, PCC. So these all are oxidizing agent. Oxidizing agent. See, at this point then. Now see the next part, phenolic part. So first question asked in 2020. So which of the following substituted phenol is the strongest acid? So I will write the structure then. So this is the benzene part. Here OH group is there, phenol. Here nitro group is attached. Next structure is, here OH is there, phenol, OCH3 is attached. Next in C option, here OH is there, C2H5 is there. Again benzene, here OH is there, CH3 is there. So you have to tell me a strongest acid, right? So I will explain this. When OH group is attached with benzene, so it is plus R effect. So this is electron donating group. Electron donating group, right? And this is electron withdrawing group, electron withdrawing group. This is electron donating group, this is electron donating group, this is electron donating, this is electron donating, this is also donating, this is also donating. So those who are donating, that increase the basicity, right? And those who are taking out the electron, that will increase the acidity. So first will be the option. First will be the strongest acid, right? So this will be the answer.